Hey you guys, this is notes number 15, slope fields. Okay. Go ahead and write down this FLT here. Sorry, I got debris on the iPad. Okay. So, given a derivative, you're going to be able to sketch something called a slope field, okay, to get a visual on the behavior of the function. So, to give you an idea of what that really means, here's a little bit of a warm-up for you guys, okay? Recall this one question here, okay, way back in the day when you were dealing with derivatives, okay? I want you to pause this video here. If I give you this equation, how do you find dy dx, okay? Press play whenever you're ready. Okay, if you need a refresher, this was way back when we did something called implicit differentiation. Okay, which is pretty much how do you take a derivative when you have an implicit equation. So remember, when you have an equation where y is not by itself or it's not all in terms of x, you know you have to do implicit differentiation. So that's pretty much the derivative, but with respect to that variable. So in this case, the derivative of x squared is 2x with respect to x. And this one here is 2y with respect to y. And the derivative of 12 is just 0 because it's a constant. Okay, then we divide each differential by dx. So then we're going to have 2x plus 2y dy dx is equal to 0. Okay, last step is you try to get dy dx by itself. So basically dy dx, if you move things around, it'll be negative 2x divided by the 2y. And that's pretty much negative x over y if you want to reduce. Okay, so what you're learning today is if you're given a derivative, can you get an idea of what the original function looks like? Okay, so this right here is the graphical approach. And then later on, you're going to learn, well, how do I find it analytically? Okay, and then when you get to BC, how do I find it numerically? So we're always trying to touch bases with those three big ideas there, okay? Okay, so if I gave you a derivative, can I get a sense of what the original function looks like, or equation at least? Okay, that's the idea. And this is what we call slope fields. It's a field of slopes, all right? So go ahead and jot this one down here. And we're going to go ahead and draw an x and y axes from -2 to 2. Okay? Sketch a slope field for the differential equation y prime equals x minus y. Press play when you're ready, okay? So some things to note. So they give you a differential equation. Sometimes they'll write it as dy over dx instead of y prime equals x minus y. Okay, so those two equations are really the same thing. What you're doing here is you're trying to figure out what the slope is at certain points. Hence slope fields, okay? So what we're going to do is we're going to pay attention to a few points. We won't do all of them. But here what we're going to do is we're just going to create points at every whole point. So there's a bunch here, but we're not going to do all of them. And on the AP exam, they won't ask you to do this many either, but at least this way you guys get some practice, okay? So for instance, let's say we're looking at this point right there, okay? That right there is 2, 1, where x is 2 and y is 1. What we're going to do here is we're going to plug it in. 2 minus 1 is equal to 1. So we know that the slope at that point is a positive 1. Okay? So what we're going to do there is we're going to draw a short little line with a positive slope. So I'll draw something like this. Notice how that line is going upwards, okay? You don't draw it all the way through. Let's do another one here. Let's pick this point right here. That is 1, 0. So if I plug in 1 and 0, I also get 1, right? So that's going to have a positive slope of 1. All right, let's keep going. Let's say we look at the origin right there. That's 0, 0. So 0 minus 0 is 0. How do you draw a slope of 0? That's really just a horizontal line. Okay? So we're going to do a bunch. Feel free to do the whole thing, okay? But I'm just going to point out a few. So let's look at maybe this one right here. Negative 2, 0. Negative 2 minus 0 is negative 2. Notice how that slope is negative, so it's going to go downwards. Okay? I'm going to go ahead and focus on this one now. Negative 1, 0, which is negative 1 minus 0 is negative 1. Now, here's where you want to pay attention. That also has a negative slope, but it's not as negative as that previous one. So it'll be a negative slope, but not as steep. So notice how this one here is steeper because it was a negative 2. This one is more shallow because it was a slope of negative 1. It doesn't matter how you draw it as long as one is relatively steeper than the other. So it's all relative, okay? So as long as this one here looks obviously steeper than this one, then you're good to go. This is number 6 on your FRQ exam. Almost always, 99% of the time, okay? I'll do one more. Let's do right here, 1, negative 1. So 1 minus negative 1 is a positive 2. So positive 2 is definitely steeper than this one here because that one was a positive 1. So I need to visually make it steeper. So that means just more vertical. All right. And then that's the whole idea. You fill all of it out and it gives you a slope field, a field of slopes. Okay. Okay. So let me get straight to the multiple choices. And you should have gotten this PDF through Text and Remind. Let me know if you didn't. Sometimes you'll get a multiple choice question on your AP exam. Match the derivative with the slope field, okay? So here's what you do. You pick some easy points that are identifiable, okay? Notice how in these slope fields, we're going from negative 2 to 2. So every tick mark is like 1 here, okay? You want to focus on the ones that have a 0 slope, okay? Or slopes that are horizontal. Notice how I have horizontal slopes all right here. Notice how I have slopes, horizontal slopes all right here. And I have horizontal slopes all right here, right? So what you want to do is you want to pick a very unique point. By unique, what I mean by that is you want to pick a point where the x and y coordinates are not necessarily the same. So, for instance, I'll pick this one, which is 0, 2. Okay? Now, if I plug in 0 and 2 into my differential equations, I have 3 choices here, I should get 0. And if I don't get 0, I know it's not the correct match. So here we go. 0 plus 2 is 2. 0, 2. The only one that comes out to 0 is Roman numeral number 2. So I know that 2 will match up with choice A here. Okay, pretty easy to do. Let's take at B. take a look at B here. If I pick a very unique point, like for instance, I don't want to pick this one because that's 0, 0. The coordinates are the same. You want to pick something that's slightly different. So I'll pick, I don't know, let's say this one here. That right there is -1, 1. So if I plug it into my choices, I should get 0 because that's a horizontal slope, or horizontal line, I should say. So the only one that does that is the first choice. So I know that that has to be it for B. Okay? And just by process of elimination, this has to be 3, right? But if I pick, I don't know, 1, 0 here, you notice that this one has to come out to 0. Pretty easy to do, all right? Here's the last part. Or here's another one for you to try, I should say. Oh gosh, the units are really tough to see. You know what? Let's skip that one. Here's the last one. This one is a little bit different because you are matching the slope field with the equation, the original function. So it's not as easy as just focusing on the slope like the last problem here, okay? Notice how the choices in the last one were all derivatives, right? So we were able to focus on points. But when you're dealing with the original function, what you're doing here is you're trying to see which slope field behaves like which of these functions here, okay? So here's what I mean. If you stand anywhere, okay? Let's say right here at that red point. Notice how when you follow it, they all go at a downwards trend here. They all follow this downwards linear motion, right? Now, over here, number 4, they kind of go upwards, and then you have a horizontal line there, and then they all kind of go downwards. Something kind of like this. If you've ever seen like the weather forecast where you're looking at weather conditions, they all follow these vectors, okay? It's really that's really what it is, okay? Number 3 here starts off horizontal and then it kind of just shoots up with its slope. Kind of goes in this motion here. Okay? And this one here, it kind of goes upwards and then goes upwards some more. Right? So we have these 4 functions. We can tell that e to the x is something exponential. It looks a lot like number 3 right here. Okay? Number 2 looks like something linear, downward linear. So that looks like choice A here. Number 4 looks like something parabolic but upside down. So that's definitely B. Okay? And tangent looks like that. So it's really easy to match. You know, some people get confused like, well, Mr. Lee, where do I start in the slope field? You kind of just start anywhere and you follow it in its entirety, right? So if we look at this one more time, you look at all these slopes, they're all starting off by going upwards, and then eventually it gets less shallow, and then it starts dipping downwards. So you kind of get a sense of its overall shape. It's going upwards then downwards, so that kind of looks like a parabola there. But that's pretty much it. These are your easy points on the AP exam, all right? So know how to draw slopes on a slope field and know how to match, okay?